We were talking about multi-step conversion problems. Here's a word problem. This one has a few more words. A running track measures 1,056 feet per lap. To run 15.0 kilometers, how many laps should you run? Maybe an odd question, but a practical type of question. So we can use dimensional analysis to solve this problem. We read through the problem. Now we're going to identify what these numbers are. Sometimes that looks like just writing things down. It's the numbers that are really important. The words you need, but the numbers are what's important. So I'm just going to write down the numbers. 1,056 feet. And in math, how would we indicate per lap? A slash. That means a fraction. I would encourage you to use vertical fractions instead of horizontal fractions, where it's just a slash. Do a numerator and a denominator. So there's 1,056 feet per lap. And then we've got 15 kilometers. I'll write that over here. We've got 15.0 kilometers. And then at the end in parentheses, we've got 1 mile equals 5,280 feet. So that's in there. This is being in parentheses. That's a conversion factor, a relationship that's just kind of given to you so you don't have to go look it up. So really there's two numbers given in the problem. And what we have to figure out is, what do we start with? And if you're not sure about that, then ask yourself, well, what am I trying to find? What are we trying to find? The number of laps. So I'm going to make my path, and we're going to end up with laps. Now we're not sure what we're starting with. It's got to be one of these. This is a per unit, feet per lap. That's a relationship between two different units. That's probably going to show up as a conversion factor. And then we have this other number, 15 kilometers. That's just a single unit. That can't be used to convert anything. So this is probably what we're going to need to start with. So we're starting with kilometers, and we need to get to laps. So this is a little more involved than the other ones we've done before. Sometimes you can just start at the beginning and go through, and sometimes you're like, I don't know. Start at the end and work your way backwards. So kilometers, nothing is jumping out at me with any of these other things, but here, this relates feet and laps. So if I had the number of feet, this would allow me to figure out how many laps, right? So if I had feet, I could get to laps. Well, how can I get from kilometers to feet? Pardon me? I could go from kilometers to miles. They gave me this relationship, miles and feet. So if I have miles in here, I could get to feet. Now, do you know off the top of your head what the relationship between miles and kilometers is? I know it's a 6 something. Is 1.6 or 0.6?
1.609 kilometers in a mile, or 0.62137 miles in a kilometer.
Awesome. Okay, so I remember roughly, but I tend to forget. So then you go look it up. And if this was an exam question, I would give that to you because I don't expect you to remember that. But we can look this one up, and so we can get from kilometers to miles. Any questions about getting the path? Yes? This would have to be looked up if you were like doing a homework problem. And one place you can get something like that is, where'd it go? Come on. It's back here. There. Okay. So here we have kilometers to miles. This is the other variation where the 1 is in front of kilometers instead of the 1 being in front of miles. Either one will work. Since he had that one so handy, we're just going to use that. But yeah, you'd look it up. Okay, once we have the path, we are set. We make a long equation, and this time we have 3 arrows, so we're going to have 3 fractions. We're going to start with 15 kilometers, and I'm going to make 3 fractions, because the path tells me to do that. Kilometers to miles to feet to laps. Those are the units that go on the top. So I already have kilometers, and then I've got miles and feet and laps. Dimensional analysis or unit analysis, we're using the units to figure out what to do. They tell us what to do. We have to put the units in so they cancel out. So I want kilometers in the denominator, so the kilometers will cancel out. Could somebody get that door? That elevator, or whatever is out there is really loud. Thank you. And then we'll put miles down here, so those cancel out, and feet down here, so those cancel out. Once the units are in place, I put in the numbers. Well, I've got this guy, which was given in the problem. There are 1,056 feet per lap. That is something that is true of this particular track. It's not a general truth, but it's true for this problem. So 1,056 is the number in front of feet. So I put that on the bottom because that's where feet is. And what number is in front of lap here? A 1. We didn't write it, but if we had to put a number, we'd put a 1. And sometimes students are bothered if there's no number, so go ahead and put a 1 there. Now, feet and miles, that was given up here. 1 mile equals 5,280 feet. In each of these fractions, what's on the top is equal to what's on the bottom. A mile is the same distance as 5,280 feet. They are different names for the same length. And then miles and kilometers. So 1.609 kilometers is equal to 1 mile. Any questions? Now, to do the calculation, I recommend starting at the left, just like you would read, and go across and multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. You can skip the ones if you want, but that bothers some people. So 15 times 1 divided by 1.609 times 5,280 divided by 1 times 1 divided by 1,056. And then I'm going to write down what my calculator says. 46.6128028 laps. Anybody else get 46? Okay. What about significant figures? Three. So 15.0 kilometers is our starting number, and that has 3 significant figures. The 1.609 kilometers to miles, that's not exact, but that has 4 sig figs. This one is exact because it's within the metric system. And this one was defined for us, but 1,056 has 4 significant figures. So we should have 3, and we're going to write, you should run 46.6 laps. Any questions? This technique, dimensional analysis, is very, very useful in everyday life. You can do all sorts of things. It doesn't pop up necessarily every day, but you can buy the large dog flea medicine and figure out how much to put on your small cat by doing unit conversions. Now, I would only do that if you were good at them, right? Make sure that you're good at them, or you could kill the cat. That would be bad. Oops. Okay, I'll find myself. Here we are.